At one time, PLCs from various manufacturers differed significantly in their design and how they were programmed. This caused considerable difficulty for users, and as PLCs increased in use and complexity, pressure grew to standardize some aspects of PLC design and programming. As a result, PLC manufacturers, in cooperation with the International Electrotechnical Commission, IEC, developed a PLC standard that is today known as IEC 61131. IEC 61131 is a multi-part standard that includes general information, equipment requirements and tests, programming languages, user guidelines, communications, functional safety, and additional information. Manufacturers' adherence to the IEC 61131 standard makes it easier for users to program, operate, and maintain systems from multiple suppliers, and makes it easier to learn and apply new systems. Fueled by the development of the IEC 61131 specification, control equipment suppliers and other interested parties formed the PLC Open organization to define and promote open standards aimed at reducing PLC-related engineering costs. Much of the work of this organization has been centered on Part 3 of the IEC 61131 standard, IEC 61131-3. Additional efforts of this organization have focused on topics such as motion control, functional safety, and data formats. IEC 61131-3 covers the following important PLC programming topics: data types, variables, program organization units, POUs, and programming languages. Data values are stored in PLC memory as ones and zeros. Each 1 or 0 is referred to as a bit. The meaning of these ones and zeros is impossible to determine unless you know how many bits are being used to represent a value and the way that value is being interpreted. As a result, the IEC 61131-3 specification describes data types and how they should be interpreted by instructions in a PLC program. There are many data types, and the number of bits involved typically range in length from 1 bit to 64 bits. The Boolean data type, sometimes referred to as bool, is used for 1-bit data values. Bit strings are consecutive bits where each bit can be individually manipulated. There are multiple data types for storing numerical values. Some are for signed integers, whole numbers, some are for unsigned integers, and some are for real numbers, often called floating point numbers. In addition, there are data types for time, time and date, pointers, and other types of values. PLC programs work with data stored in memory locations referred to as addresses, and instructions in the program must identify associated addresses. This is done using variables. A variable can be displayed as an absolute memory address, such as I2.3 or Q3.0. This type of variable is preceded by a % to show that it is a global variable, meaning that it is available for use throughout the program. The IEC 61131-3 specification also allows symbolic variables to be used. Symbolic variables, also called tags, have names that also use alphanumeric characters, but are intended to be representative of a function being performed, such as stop motor 1 or start motor 1. Symbolic variables are enclosed in quotation marks when they are global variables, but symbolic variables can also be local variables, which means they are available only to one part of a program called a Program Organization Unit, POU, also called a program block. Local variables are preceded by the # symbol. Variables used in a PLC program must be declared in the table. The appearance of the table may differ from the one shown in the accompanying graphic, and additional data may be included. However, this type of table is critical because it associates an absolute address with the symbolic variable name and also identifies other important information such as the data type. A variable name is also referred to as an identifier. Picking a good identifier is important because it makes the program easier to understand. The IEC 61131-3 specification provides only limited guidance on the choice of identifiers. However, the Siemens Programming Style Guide for S71200/S71500, discussed later in this course, provides additional useful information. For example, a symbolic variable identifier should have the following characteristics. An identifier must be unique, meaning that it must be different from other identifiers. And identifiers that differ only in the case of letters used are also not permitted. An identifier must begin with a small letter, but subsequent words included in the identifier should be capitalized. This is referred to as camel casing notation. An identifier must not be more than 24 characters. No special language characters should be used. Blank spaces and separators should not be used. An identifier should be meaningful. Early PLCs had all the program code in one continuous block. This is referred to as a linear program. However, as PLCs increased in capability and complexity, linear programs became difficult to develop, understand, and maintain. As a result, the IEC 61131-3 specification promoted the concept of Program Organization Units, POUs, which are also called program blocks. A program block contains a portion of a program. The specification also describes a type of program block called a function block, which has an associated data block to store related information, and a function which does not have a data block. Use of program blocks allows for modular programming, also called structured programming, in which the main program block calls another program block when needed. Once the called block is done executing its logic, the main program block is resumed at the point where it left off. A modular program can have multiple program blocks, and if needed, a program block can be used multiple times in a single scan cycle. This reusable capability of program blocks helps to speed program development. Another feature of a modular program is program block nesting. Nesting occurs when the main program block calls another program block, which calls another program block. When the nested block completes its execution, the remainder of the calling block is completed, then the main program block is resumed. Compared to a comparable linear program, a modular program is easier to develop, understand, and maintain. The terminology associated with program blocks can be confusing, and the IEC 61131-3 specification provides only limited information. However, the Siemens Programming Style Guide for S71200/S71500 provides descriptions for these terms such as tag, tag value, actual parameter, and formal or block parameter. Additional information on the contents of the Programming Style Guide is provided later in this e-learning.